Hello everyone, this is Dilip. In the last video, we have seen normal equation method for solving linear regression. And in this video, using Google Colab, we'll see how we can implement it for a very simple problem. So this is Google Colab. If you have a Gmail account, you can also log into the URL you are seeing here and run the Python code required. It doesn't require any installation. All the TensorFlow and all the major Python libraries come pre-installed so that you can run the Python code in the browser itself. This environment, what you are seeing here, is otherwise referred to as Jupyter Notebook, where you can have the script, like Python script, as well as your text, like comments we want to put in a single flow. So whatever the program I'm showing over here, I'll again leave a link to it in the description so that you can go and check it out and do it for yourself. Okay. So first thing is we'll import the NumPy Python libraries. Import NumPy as NP. Let's have the following test data where x equal to 1, 2, 3, 4, 5, 6 and y equal to 1, 2, 3, 4, 5, 6. So these are test data. So in simple terms, when x is 1, y is 1, when x is 2, y equal to 2, x equal to 3, y equal to 3. So you can see this simply just y equal to x. So our hypothesis will be h of x equal to x. So for h of x to become x, theta 0 should be 0 and theta 1 should be 1. So let's see how our normal equation method solves this. So we are taking x as np.array. Remember earlier I was telling, along with this theta 0, we'll also assume there is one more parameter, x0, which is nothing but its value is always 1. So we are initializing the first value of this matrix with ones, as you can see, and the second value with the data, so which is nothing but 1, 2, 3, 4, 5, 6. So that's what I am filling out here. Okay, and then I'm also writing out the test data. Sorry, test result, which is 1, 2, 3, 4, 5, 6, which are our results. So let's print x. Along with that, we'll also print y as well. Let's see how they look. So you can see this is a 6 cross 2 matrix, and this is a 6 cross 1 matrix, x and y, and all the x zeros are ones because theta 0 and x 0. So our formula for normal equation method is x transpose x whole inverse dot x transpose of y. So let's do step by step. So first thing is calculating of x transpose. So that's a simple to do in using the NumPy inbuilt libraries. So you just do x dot t. This will give us the transpose of that matrix. So let's store that in temp1 and print that temp1. As you can see, a 6 cross 2 matrix got transformed to a 2 cross 6 matrix. As you know, the transpose will do rows into columns and columns into rows. And okay, let's go to the next step. Next step is matrix multiplication, x transpose multiplied with x. So that is represented with dot, and element wise multiplication is represented with multiply. Element wise is nothing but this one you will multiply with first one, this second in the first row you will multiply with second in the first row, like that you will go on. So that is not proper matrix multiplication, that is just element wise multiplication. So this notation, why it is like this, even I don't know, because otherwise the name should be dot for this and multiply for this, but let's go with it. So since you need matrix multiplication, let's use the dot. So np dot dot this x transpose with x. So x transpose is stored in temp1. So temp1 multiplied with x. That will give us temp2. So let's print it out. Since I've already run this, you can see the output beforehand here. And to compute the inverse of this matrix, we use P inverse, which is nothing but a pseudo inverse. So np dot linear algebra library, from that you take the pseudo inverse function and calculate. Since you are storing this whole value in temp2, we'll calculate a pseudo inverse for temp2. So remember, as I said earlier, not all matrices have inverses. So singular matrices don't have inverses. What this pseudo inverse does is, if matrix has an inverse, it will calculate the inverse and give us. If it doesn't have an inverse, it will calculate an inverse which is closer to that matrix. So closer to that original matrix. So if the original matrix doesn't have an inverse, it will take one another matrix which is very close to that, which values are very close to that, and it will calculate the inverse and give it to us. So this way we can avoid the pitfall when giving our program to anyone, such that it won't fail at this point if the matrix doesn't have a inverse. So there is instead of PINV, you can use INV also, but using that will not give us an inverse for matrix is singular. So let's use the senior inverse, P inverse, pseudo inverse, and print it out. So this will give us this value. So for the temp2 matrix, which is x transpose of x, this is our pseudo inverse. Let's run it out. Okay. Now let's compute the second part of the equation, which is nothing but x transpose multiplied by y. Since we are storing the x transpose in temp1, so np dot temp1 comma y. X transpose y is printed here. So here I'm giving it some meaningful names, such that, well, in the end we'll have a better view. So let's see. Now x transpose x of whole inverse matrix multiplied with x transpose of y. So np dot dot the first one and the second one, and you can see the output here. And this is 1 multiplied by approximately 10 to the power minus 14, which is nothing but so close to 0. And this is just 1. So you can take this as 0 comma 1. So this is approximately theta 0 is 0 and theta 1 is 1. So in our hypothesis, we can see our equation will become h of x will become 0 plus 1 multiplied by x, which is nothing but h of x equal to x, which exactly fits our data. Thanks everyone for watching the video. Hope this video helped you in getting a programmatic understanding of how the normal equation method works. Bye.